So just pulling up the agenda on my phone, I believe, first up, we have Smith from the Space Studies Institute. Now, Robert told me not to introduce him and not to give advice, so I'm not going to. I'm just going to say, when I first met Robert, I said, "Hi Robert," he says, "My name's Smith." I think that's all you need to know. He's going to be a proper showman. He's got a lot to tell us, and we're looking forward to everything he wants to. Smith, sorry.
Where are we going? I gotta start recording because I'm a librarian. Can you hear me?
Yes.
Yeah?
Yes.
First off, before I say anything else, I hate listening. Second off, to Sanjay, to Isa Solaris, UK Space Agency, to all the sponsors, to all the presenters, and to everyone who's been so nice upstairs, I was really afraid, you know, in the European accents, when you're in the presence of God. This has been one of the most amazing conferences I've ever been to. And that is the absolute truth. This is really amazing. So to everyone who's worked on this, touche. It's really good. Second thing I want to say is, I was tasked with making a message to government people. So if you're not a government person, stick around. I'm probably going to fall off the stage. That's entertaining. If you are a government person, hi there. The third thing I want to say is, I'm going to read my presentation. That is because when I start talking about space, I start getting really excited. And I get off on tangents. And I don't want to do that because this is an important message. I think this is an important message. Let's see if we can get my presentation up. Can we get my presentation up? There we go, that's the start. All right, so like I said, I'm going to read this. It sounds like I'm reading. But I'm doing this in respect to you so I don't get off tangent. Good afternoon. I wrote that, good afternoon. As you may have figured out, we presenters have limited time, and because I have decades to cover, I'm going to follow my script. So we're going to just jump right in. With a reminder of the giants on whose shoulders we all stand. Has everyone here heard of the International Space University, Strasbourg, France? Okay. Well, the ISU started in Boston, Massachusetts in 1988. With a gathering that's a lot like the one that we're at here today. This is the first international space university, Boston, MIT. It was organized by SSI old-timers Peter Diamandis, Todd Hawley, and Robert Richards. And it looks a lot like us, except it's a little blurry. Technology or video at the time. However, I can clean that up a little bit. Click. There we go. We have heard this man's name. This is Dr. Makoto Nakatomo of the organization now known as JAXA. Dr. Nakatomo flew in all the way from Japan to Boston, see, international, to work for days with the students and then to sit at this table with his peers. His peers including this man. This is Dr. Peter Edward Glaser, Arthur D. Little Corp Company. He's the inventor of solar power satellites. And then there's this guy. Click. This is Bill Brown. Dr. William Brown, Raytheon Labs. This is the father of microwave power beaming. This is the man who held for decades the world record of the longest distance microwave power beaming in human history. Until this report came out just a few weeks ago. You may have seen a great presentation on this yesterday in this very room. The South Koreans announced that they beat his record. And as you see, for the first time, it was an apples-to-apples comparison because they did it in the great outdoors. As did Bill Brown. You may have heard of the Goldstone tests. 1975, Mojave Desert, California. This is the Goldstone experiment. That's the Venus site at Goldstone. The dish in the front, that's the transmitter. Way, way back in the mountaintop, way in the back, you can hardly make it out. There's the rectenna and a row of lights. I can make it a little bit clearer for you. That shows you the scale, however. In the center is the rectenna. Down underneath it, a big row of lights. When people first hear this, and they see this picture, they sometimes go, oh, those are representations of the signal being detected. Those lights, and they are huge and can be seen in the daylight, in the sunlight of the Mojave Desert, are being powered by the beam. Some of you might have actually seen a little demonstration, a little piece of this video. NASA has an itty bitty piece of the experiment on their YouTube channel. It's about this big, and it has thousands of likes. But because you're actually into this, I'm going to give you a suggestion. See the entire video. Bill Brown walks you through from before the beginning, the hand aligning the rectangle elements, the building of the experiment, the running of the experiment, and the statistics at the end. It's amazing. He voices it for you. If you really want to learn something, that's the one to watch. And you can watch it. I'm going to tell you where you can watch it in just a second. Don't let me forget. But first, I got to go back to the International Space University because this guy doing the Last Supper thing, this is Princeton professor, American nuclear and particle physicist. This is the man who is the reason you can go anywhere in the world today, say particle accelerator, and people say, yeah, big round things, duh. He's the inventor of the storage ring synchrotron, the piece of hardware that made round particle accelerators actually work. He's the reason I'm here today. This is Dr. Gerard Kitchen O'Neill, the founder and first president of my organization, the Space Studies Institute. So this is the very first International Space University. Laser, satellites, Brown, powered beaming, O'Neill, manufacturing. And it was completely dedicated to solar-powered satellites. I say that because that's what Glaser said. I've been doing this a while. I know you're supposed to say space-based solar power now. It has had many names over the years. It has come up many times over the years. Every time it comes up, some radio or TV person you hear, oh, NASA did a study decades ago. But that's not true. NASA did not do a study. NASA did many studies. And the Department of Energy did many studies, and the Department of Commerce did many studies, and the Defense Department did many studies. How many studies? Hundreds of studies. This picture isn't even the half of it, so we just shipped our collection from Princeton up to Mojave. Hundreds of studies. Thousands of pages, thousands of person hours, thousands upon thousands of American taxpayer dollars. And it all added up to not one single solar power satellite in orbit. Why is that? Because the report said it couldn't be done? Nope. It is because, as so often happens, the reports that were supposed to be a means to an end became the end unto themselves. A hardware-based technological endeavor is only going to happen if hardware is funded and built.
Amen.
Yeah. Now you have to do reports. You absolutely do have to. Governments love reports. Even though they're digital now, they still love the math. But if you get a grant of 1,000 euros, 1,000 pounds, $1,000 to move this topic along, can you still hear me? I can tell this. Okay. If you get a grant of 1,000 and you spend 800 of them on reports, that leaves 200 for hardware. Hardware is expensive, and that's not going to work. 40 years of American history on this. I got a trick for you. Here's the trick that you can do those reports, or fund those reports, and save the time and money so that the hardware can be built. You ready for this? It's really good. You stand on the shoulders of giants. You go back to the original reports, find the baseline numbers. Adjust them for inflation. Adjust them for population. Adjust them for the amount of toxicity in our atmosphere because of our continued burning of fossil fuels. Change those base numbers, the rest of the math falls into place, and your report is done. I do want to bring up a fact about all those reports that have been done before. They are not just about rectangles and transmitters. They cover site selection, frequencies, legals, military, security, affected physiological questions, a lot of things I swear your governments haven't even thought of, but they will. 40 years of reports. Once you do those, just adjust the numbers, math falls into place, report done, copy and paste the rest, I'm not going to tell anyone. You're saving time and money that you can now put into the hardware. A hardware-based technological innovation is not going to take place unless hardware is built. It is not specific to space-based solar power. That is business. Remember this guy? I told you he invented the storage ring synchrotron, a piece of hardware that made round particle accelerators actually work. He did the studies, he did his first report, 1957, the year before Sputnik. Scientific community in America said, oh my God, look at this math, it's beautiful. Literally, they did. And he said, well, the math shows that you can build these things, change particle physics forever. Scientific community says, son, science is not about hardware, science is about studies. And it languished for years until a Stanford physicist decided that he wanted to make his mark. He thought that he could detect a new particle, but he could only do it with the speeds and the power of a round particle accelerator. So he calls up Jerry O'Neill. Dude, come out to the coast, we'll have a few labs. O'Neill goes from Princeton to California. They pick through this scrap heap at Stanford University. They bring out their welding goggles and they build a demonstration unit. Government people came in, National Science Foundation types. They said, yeah, we heard about your math, big deal. Oh wait, what is this? Something we can touch, something we can see? If you guys can build this, the Soviets can do this. We have to fund this. And they did. And that first piece of tangible demonstration hardware led directly to the funding and the building of the world's first complete round particle accelerator. That first piece of tangible hardware led directly to the discovery of the psi particle. That first piece of tangible demonstration hardware led directly to the 1976 Nobel Prize in Physics. That first piece of tangible demonstration hardware led directly to your now being able to go anywhere in the world and say particle accelerator, and people say, oh yeah, big weather things, duh. Large Hadron Collider, storage ring synchrotron, Gerard Kitchen O'Neill. A hardware-based technological endeavor is only going to take place if you build the hardware. Learn from history. Because if you do not, 40 years from now, we are all going to be right back here in the same room. This table is going to be covered with piles of paper, but you will not have a single space-based solar power satellite in orbit, providing a single benefit to a single man, woman, or child in your country. For the Space Studies Institute, SSI.org, danke, merci, gracias, did I hit grazie? And from the bottom of my heart, thank you.
Ladies and gentlemen, Smith.